So here's an example of a question for an object in free fall. So really this is a lot of kinematics, but our dynamics and forces do come into play when talking about it. A penny is dropped from rest from the top of the Sears Tower in Chicago. Considering that the height of the building is 425 meters and ignoring air resistance, which is important for free fall, find the speed of the penny just before it strikes the ground. Okay. So I have this building, the Willis Tower. Change that. Willis Tower, of course. And I know that the Willis Tower is 425 meters tall. And I'm going to take a penny and I'm going to drop it. So then that means that at the beginning of this scenario, the penny is not moving. And I know that it's going to fall. And as it falls, its acceleration then is downward. And I don't know the speed right before the end, and I don't know the amount of time it falls, but I know that as it falls, it is displacing 425 meters. So if I draw a free body diagram of this penny, then what I should see if it's in free fall is that the only force acting on it is the force from the earth. So in this case, I have my penny, I have the agent of my earth, and then that's the only force on it. There's only a long-range force, and then it's falling. There are no other agents associated with this penny. So that's it. So now when I'm in free fall, I'm going to go back and think about my kinematics equations and how I talk about these. Well, I know that it starts from rest, so the initial velocity is 0. I don't know the ending velocity. I know it travels 425 meters, but notice that it's traveling 425 meters in the negative direction. So negative 425 meters. I know my acceleration is in the negative direction, negative g, which is negative 9.8 meters per second squared. This question is asking me to find the speed of the penny just before it strikes the ground. So this is what I want, and this is what I don't care about. So when I'm going through and I'm deciding, oh, which equation should I choose? Then I come up with this kinematics equation, my favorite kinematics equation. And then I can solve. So V then is the square root of V naught squared plus 2a delta x. So let's plug in. V equals the square root of 0 squared plus 2 times negative 9.8 times negative 425. So V equals, ooh, I don't know, I don't have my calculator. I know. So then here we go. 2 times that times, and then square root 91.3 meters per second. Now, if I were to take and look at the units of this, I would say that I would have the square root of meters squared per second squared for meters per second squared, plus 2 has no units, but I have meters per second squared times meters, which becomes meters squared per second squared, which goes with it. So I have the square root of meters squared per second squared, which is meters per second. So then we're good to go. Now you can follow that same process as you go through and do all of your free fall problems.